Hello, this is Mr. Collier, and today we're doing quadratic, discriminant, and inequalities. Okay, so discriminant is b squared minus 4ac. That comes from the thing under the square root sign of the quadratic formula, which is this negative b plus minus root b squared minus 4ac over 2a. Since this is positive negative square root, if b squared minus 4ac equals 0, then positive negative 0 is the same thing, and you get one solution. Okay, you get one solution. Yeah, and then if this number is positive, then you got positive negative square root, so you get two solutions. Maybe I should say two real solutions. And also, if it's less than 0, then you're square rooting a negative, so you get no real solutions. Okay, so discriminant can tell you how many solutions there are, how many real solutions. Okay, so determine the nature of each of these, so you do the discriminant. So it's b squared minus 4ac, that's 7 squared minus 4 times 5 times negative 1, that's 49. Plus 20 is 69, which is greater than 0. So there's going to be two real solutions. Okay? You could also say, since it's like square root of 69, which is not a whole number, then you could say two non-integer solutions or something like that too, if the question asks for that. Anyway, here you need to put this on to, or rearrange this in the right format. And then we'll do the discriminant. So discriminant is negative 70 squared minus 4ac. Okay, so this is 4900. 4 times 25 is 100, so that's pretty easy to do. It's 4900. So that's equal to 0, so there's one real solution. Now, the easiest thing to do with this one is to multiply both sides of the equation by 4 first, and then we got 8x squared plus 7x plus 2 equals 0. So discriminant is 7 squared minus 4ac, and this is 64. Don't even need to actually work that out. You know this is less than 0, so no real solutions. Okay, and then more commonly on IB questions, you have to do stuff like in number 2. We're given that the quadratic has exactly one solution, so we know that means discriminant equals 0. So negative k squared minus 4ac equals 0. We've got k squared minus 64 equals 0, k equals positive negative 8. Don't forget the positive and negative. Okay, so there's two possible answers. For what values of c does the quadratic equation have no real solutions? No real solutions mean discriminant less than 0. Negative 6 squared, so b squared minus 4ac is less than 0. Negative 4c is less than negative 36. This is 4c greater than 36. Remember, you divide it by a negative, you flip it around. So I could have just went straight to c is greater than 9. Okay. All right, maybe we can take a look at that graphically. So I often have Desmos open up on my computer. We can graph that, Desmos. Pop this over here. X squared minus 6x plus c. With that slider, and there we go. So if c is greater than 9, we get no real solutions. So now we're less than 9, and we get two solutions. If we go up to exactly 9, we got one solution, and greater than 9, you get no solutions. So that's what it looks like graphically. Okay, next, this one's no real solutions, so that would be discriminant less than 0. So we got b squared minus 4ac less than 0, so that's k squared plus 2k plus 1 minus 4k minus 4. Well, actually, I should be multiplying by 3 here, or basically multiplying by 12. We got 12k minus 12 less than 0, so we got k squared minus 10k minus 11 less than 0. That factorizes k minus 11, k plus 1 less than 0. Now at this point, your answer is going to be an inequality. So what values of k will give you values that are less than 0? You can look at it manually, or you can think about a little graph. This is like a quadratic that goes through -1 and 11. So less than 0 is between -1 and 11. So k is between -1 and 11. Okay, you can also try a sign diagram instead of a little graph. For a sign diagram, let's call this f of k or whatever. Sign diagram, we know that it equals 0 at -1 and 11, so then you just substitute values in between. So if you substitute 0 into this, we get -11 times 1, we get a negative. Okay. And if you substitute a number like bigger than 11, like 12, you're going to get positive times positive, you get positive. And if you substitute a number like less than -1, like -2, you're going to have negative times negative is positive. So you can see the answer is here in this interval. K is between -1 and 11. Okay, now this is very similar to before, so I'm going to skip this one for now. One repeated root, that's the same as one real root. Okay. The reason it's like called one repeated root is because like the actual quadratic might be something like y equals x minus 3 squared is the same as x minus 3, x minus 3. So it's like a repeated root, but it's really only one root on the graph, right? But it's useful to think of it as one repeated root for things we do later. We need to, okay, so you have some solving inequalities here. Let's check out this one. Let's check them all out. So let's look at this one here first. Let's factorize this quadratic. So 2 times 15 is 30. So we need two numbers that multiply to give you multiply to give you 30, add to give you -11, that's -6, -5. So you got 2x minus 6x minus 5x plus 15 less than 0. So factor out 2x. Get 2x minus 5, x minus 3 less than 0. This again is a quadratic that's facing up. We've got solutions at 5/2 and 3. So this means x is between 3 and 5/2 is the solution. Okay, let's look at this first one. -6, -5, or I got it backwards, -6, -5. That would be -6 times 1 gives you -6. So it's 2x squared minus 6x plus 1x minus 3 greater than or equal to 0. Okay, in this case we got 2x plus 1, x minus 3 greater than or equal to 0. Alright, so that's greater than or equal to 0. This is a quadratic with roots -1/2 and 3. So greater than 0 is here and here. Okay, so that's x greater than 3 union x less than -1/2. Okay, now this one's a cubic. So let's factor it like this first. And this factorizes nicely. Now if you don't know what a cubic is, you can make a sign diagram like I did before, but cubics go like this. Let's write in the roots first. We're going to root at -2, -1, and at 0. So your cubic is going to go like that. Okay, so we're looking at less than or equal to 0. It's two sections. x is less than, and there's an equal to sign here. Oh, I should have done that over here too, look. Equal to is possible. So less than or equal to -2 union x is between 0 and -1. Okay, so there's two sections here. Okay, lastly, here's a discriminant question. This is a past IB question. Here's a function and a line. The line intersects the graph at two distinct points. Find the possible values of p. So think about how you find the points of intersection. To find points of intersection, you set them equal to each other, solve for x. If there's 2 points of intersections, that means there's 2 solutions when you set these equal to each other. So let's set them equal to each other. That finds the points of intersection. And solve for x. X is in the denominator here, so we multiply both sides by x. So 0 equals x squared minus 2px, if I bring this px over here. And actually, okay, now we can look at discriminant. Two distinct points mean discriminant is greater than 0. So b squared minus 4ac is greater than 0. That's 4p squared plus, I'm going to leave it as 4 times 16 because I can divide by 4. You get p squared plus 16 greater than 0. I suspect I've made a mistake. I think this is supposed to be negative, otherwise it doesn't work. Let me double check. Okay, let's see. This when the 16 came over, that should be positive. Positive. Negative. Negative. Now it makes sense. Now don't just square root, you can factorize it. And again, look at or think about this solution. We're at -4 to 4. Look, greater than 0 gives you p greater than 4, like this section of the parabola, and p is less than -4. Okay, let's check that out on Desmos. It's always interesting to check that out on Desmos, that kind of stuff. So y equals p minus 16 over x. P minus 16 over x. Put in a slider for p, and then y equals, is it x minus p? X minus p. Okay, right now there's no solutions here. But we said the solution is when p is greater than 4, so let's bump up p to 4. So at 4 is one solution, 1 point of intersection, and greater than 4 you get 2 points of intersection. And then over here, -4, we get 1 point of intersection. And then less than -4, we get 2 points of intersection. In between -4 and 4, you get no points of intersection. So the graph here on Desmos totally matches what we just did algebraically.